Hello and welcome back. Today on the bench we've got this mock-up, a prototype of a tone circuit for the 6146 amplifier. The one channel of the 6146 amplifier, the output stage and everything, the phase splitter, that's all sort of done. We just need to figure out the input and the tone control, and we're having a few issues. And we step over this way. This is what we've got there. So this is the basic tone control circuit there. It's basically a passive tone control circuit. But the problem is it's lossy like all tone circuits. So if we put 1 volt in here, we only get 0.14 something like that out. So to try and mitigate losses, what I've got here is your normal sort of voltage amplifier using a triode. All this is using two 12 AU7s ECC 82s. So we've got a pretty basic circuit, which is what you see on all 2 SN7 ECC 82 6CG7s. Pretty simple. 47k, 1k5 cathode resistor, 470k grid leak. And hopefully, I was hoping that would increase the input, and so when it does come out, okay, it's going to drop, but at least we should get more out. On the outward bound stage, as it were, I've got a cathode follower as a buffer for the tone control circuit. Pretty simple, 33k, what do you call it, resistor, tail resistor there. Cathode resistor, sorry, not quite balanced, done this right. Got a grid leak there, 470k or a 1 meg, I can't remember now. 3k3 there to give us a bias, and then I've got another triode of the 12AU7, 100k resistor this time to give us a bit more gain, and 1k cathode resistor, partially bypassed by a 100U capacitor, and this 330R here is basically so we've got somewhere to stick our negative feedback in. The problem I've got with this is that when the tone controls are set to midway, as it were, it's not a flat frequency response, which I'll show you now. So I'm pointing you at the HB8903, and like I said, this is our output. This is our output at 1 kilohertz. Right, watch when I put in 100 hertz. It's shot up to over 8 volts, so we've got a right bump in the low frequency response. Frequency 5 kilohertz. Right, it's still higher. Frequency 10 kilohertz. Gone down again. So basically it's all over the shop. So I'm going to go and turn this off. Let me just knock this back to 1k. Basically, as far as I know, your tone controls, we want them to leave the mids alone. So I think basically somewhere from like 400 hertz to say 5k, something like that. Don't quote me on that. We want those to remain flat. They want to be left alone. We only want to boost the low frequencies and the high frequencies, and obviously this isn't doing that. I'm just going to go and turn this off. Got it powered by 2 bench power supplies. So originally I had this as a cathode follower input, with the output as you saw, but I have a few options. I don't think, obviously this isn't working, so where are we? Here's my pen. On the amplifier I'm basically limited to 2 bulb bases, so I've got like one here and one here, and for either side. So basically I've got half a triode and then whatever here, so I could have like 2 triodes here, like a double triode, like an ECC 83, 82, and I can have half a triode here, say something like a ECC82 at 12AU7. So yeah, a lot of decisions to make, and a lot of issues to solve. Well, here we are sometime later. In the meantime, a long time has passed. I've been down quite a few rabbit holes and jumped through several hoops, and got nowhere really. But however, this circuit is working, but there is a problem. So anyway, let's demonstrate it. Basically what I'm trying to do at the moment, I'm running a frequency sweep from 20 Hz to 50 kHz, and these are the controls set at mid-level, so we should see basically this reading here, which is in volts, RMS volts. We should see that not change much. So there we go, 20 Hz, 1.1, so we've got a bit of a bump. Okay, so far good. 1 kHz ish, about 3 kHz. It starts dropping a little bit. 25 kHz, we're dropping. Right, now let's do that in dB. So now we're in dB. Forget the minus, 2 dB. What we should be seeing something less than, basically, if this figure here moves more than plus or minus 3, then our frequency sweep is not flat. So a little bit of movement is okay. 1 dB is okay, so it could go to 3 or 1, that would be okay. So let's run that sweep again. 3 dB. Right, so we've got quite a bit of a change there. Okay, let me just set the frequency back to 1 kHz. Okay, so not brilliant, but I'm not quite sure that I've got this resistor across here quite right. This needs some trimming, and the actual controls might not be set bang on midway. It's a bit hard to know. As you know, with a pot, they don't go like 360 degrees, it's something more like 270 degrees, and trying to figure out whether you've got the pot set to midway is tricky. So what has been the problem? Well, this circuit works. It functions as a tone control. So let me bang this on 100 Hz. Right, this is the bass control. Cut, boost. We're going from about a range of, right, hang on, let me just see there, 1.7 dB midway. Cut is about 1 dB. Boost is a little bit more than 2 dB. Now let's pop that on 5. Cut is about 3 dB. Boost is about 5 dB. So not perfect. The problem I've had with this tone control is, on our 6146 amplifier we've got 2 valve bases there. So essentially we've got 3 triodes, or 3 valves. So I've tried using an ECF82 and using the pentode as a higher gain, as a higher gain stage, to try and get more than unity gain out of this tone control, but I don't think there is a way that you can do that. The gain has to be pretty bang on. Too much and you've got too much feedback and it won't work. Too little and the same applies. It's a very touchy circuit. I tried a passive tone control, we tried that, that didn't work. and so this is where we've come to. So basically we're using both triodes of an ECC82 12AU7 and one triode of a ECC83 12AX7. That's all well and good, but I mean it works. It needs a bit of tweaking, but yeah, we're there. However, on our 6146 amplifier we've got two holes there for the valve bases. That's it, that's unfilled up. So what we need to do now, we need to give this, the output, some gain. Well, we can't, because we haven't got we haven't got a spare room. We haven't got any spare room. The only way I can really do it is either to put a valve inside the chassis, or to use like something like a op amp to give it some gain, which is probable. So it's not an ideal solution. What I've been trying to do is trying to up the gain by using, like I say, an EC AF82 pentode and things of that nature, and it's just not working. So, however, we've got a gain control that sort of works. It's got valves, and that's better than nothing. I'm a bit tired of doing this. I've been at it about a week on and off, so yeah, I'm a bit fed up. I'd like to move on and just get the amplifier built. If you look online and actually try to find out more about hi-fi valve amplifier or tube amplifier tone controls, there isn't a lot out there. There really isn't. There's several circuits, but a lot of them are older circuits, like in the RCA manual and things of that nature, and they all use things like 2 meg pots and stuff like that. The other problem with tone controls, and if you've ever tried to build an RIAA phono stage, the problem you run into is capacitance values. A lot of the capacitance values that are used are just really uncommon. Things like 240 picofarads or 180 nanofarads and 1800, whatever, really uncommon values. And so what you end up doing, well, it's been driving me mad. Like, as you can see, these are all some of the components I've been trying to do. So I've been trying to parallel capacitors, put them in series and parallel, and God knows what. It's, yeah, like I say, several rabbit holes. So anyway, I'm going to get this bugger built, and somehow I'm going to have to put a gain stage at the end of it, and maybe tweak the volume control and what have you. But for now, I mean, I'm just fed up with this, and it'll just have to do. It'll do the job, and that's all that matters. We'll bung it in the amp and get it built and test it. Okay, we've got the tone control in. As you can see, that's sort of working. We still might need to just play with the volume of this capacitor here though. Everything's working pretty much, apart from we've developed a couple of sort of issues with this screen grid supply. So I'll stop shaking the camera about. With this screen grid supply, everything was working fine, and then yesterday it started breathing, which is sort of motorboating, sort of, but it's not quite that. Basically what was happening yesterday, it started like ticking, very low frequency ticking, go tick, tick, tick. And then I monitored the screen grid voltage, which should be 175 volts, and it wasn't. It was going up and down all over the place. So I connected it up to my big power supply, and that stopped. So there could be an issue with this. So I had a look at it, and then I noticed this, which is a ground lead, which is loose. So anyway, I connected a sort of separate ground lead up, and that didn't solve the issue, so we could have a problem with this. What else have we done since I took the last video? We've been playing with our dropper resistor values to get our voltages as spot on as we can. So we want 350 volt on our cathode followers, we want 300 volt on our phase splitter, and then we want 250 volts on our tone section sort of voltage amplifier, which is down there. It's all sort of crammed in. We have another potential issue on this cathode follower, which is the input cathode follower, in that I think some of the voltages are wrong there, although the amplifier works. Another issue I've got is that the heater voltage on the preamp valves, cathode followers, etc. is a bit high, so I've just had to pop that 0.47 ohm resistor in just to lower that a bit. I was hoping it would drop with more valves in, which it may do. Another issue I had was with the board that we had in there, which was one of these chopped down, and it was sort of bodged together, and I couldn't really fit the, we've got here, we've elevated our heaters, so we've just got a potential divider going from 420 volts to ground, and then we get about 50 volts out, and that's applied to the wiper of this little pot down here, and that sits across the wiper, the heater voltages, and that just raises the heater cathodes to about 50 volts as mentioned. And that's because the cathode followers, the cathode sits at about 70-80 volts. So I think for the ECC 82 it's something like 200 volts heater cathode maximum voltage. So anyway, we just elevate those voltages just so the cathode isn't quite, isn't sitting at a high potential in relation to the heaters, and that means that our voltage, common triode gain stage, that's sort of elevated as well, but that's not a bad thing because it can alleviate any hum that we may get. So as you can see, we've got a few sort of temporary wires in here just to get the thing working at the moment. Now I've got all the values correct, I shall tidy some of this up, and then we'll have a look at the screen grid supply, see what's going off there. I don't know, it could be anything. I'll take a few voltages like always and see where that gets us. We're jumping forward into the future again a little bit here. So as you can see from that video, I've had quite a lot of problems trying to sort out the tone control, and just about got that sorted, only to be met with several other issues. It's not been a straightforward build at all. I'm getting there slowly, but I keep getting several issues that keep popping up. A lot of these issues are bad planning on my part, and also I didn't quite wind these transformers correctly, which you will see in the next video, and we'll hopefully get into the nitty-gritty of it and hopefully finally get this amplifier running stable without any shenanigans. Thanks very much for watching, take care of yourselves, ta-ra for now.